The gestation time for humans has a mean of 266 days, right? So this is the population mean mu, because it's for humans, it's for a large amount, right? Maybe everybody. So that's mu equals 266 days. And the standard deviation, so the population standard deviation sigma in this question is 25. Now we can put in days there if you like as well, right? Days, sigma, the population standard deviation. If 100 women are randomly selected, so that's a sample of 100 women, and the sample size is 100. Find the probability that they have a mean pregnancy between 266 days and 268 days, right? So that's getting the mean of the 100, if you like, if you know what I mean, right? So X bar, in one sense, X bar, that's the sample mean, that's the mean of the 100, would be 266 days. And the other scenario there is X bar equals 268 days. And we want to find out the probability. If you just draw one sample of 100 from this population, what's the probability that the sample, that mean will have a sample between 266 days and 268 days? Now, the way we're going to do that, well, we could draw out, what are we going to do? We need to use a few formulas, right? For the sampling distribution of the mean, we're going to get Z scores. We're going to get a Z score here, let's call that Z sub 1, and we're going to get a Z score here, Z sub 2. Now, to get a Z score for this situation where you have a sample, it's going to be X bar minus mu over sigma over root n, right? Where X bar is the sample. So for Z1, X bar is going to be 266. For Z2, X bar is going to be 268. The rest of the stuff stays the same. So I'm going to scroll down here a little bit. Now, let's calculate Z1. Z1 is going to equal 266 minus, so if X bar is 266 minus 266, so you're going to see it's going to be 0 on top. And we're going to have sigma over root n underneath, that's 25 over the square root of 100. So this is going to work out to be 0. Z1 is 0. And Z2 is going to be the same thing again, except the X bar position here will be 268 minus 266 over 25 over root 100, which is 10. You know, so we can work out Z2 here kind of without the calculator. On top we're going to have 268 minus 266 gives us 2. And underneath 25 divided by 10 is 2.5. So we've 2 divided by 2.5. So that's going to be like 4 over 5, I think, or 0.8, but we'll just run that through the calculator. So I'm going to have, the calculator's a bit wonky here, I'll move it to my other screen. So I have 2 divided by 2.5, and I have 4 over 5, which is equivalent to a decimal of 0.8. Right? So what have we got now? We have Z1 equals 0 and Z2 equals 0.8. Now, the probability that we have a mean between 266 and 268 is going to be equivalent to the probability of getting a Z score between 0 and 0.8. Right? And you can look this up in the back of the exam table or in your log tables. And here's our Z distribution. Right? We always have 0 here in the middle. And then we've 1, 2, 3 standard deviations out to there. 1, 2, and minus 1, minus 2, and minus 3 standard deviations this way. Right? And Z equals 0.8 is just going to be about here, roughly here. And Z equals 0 is this center line. So we're looking for this area here. The area, remember the area is equivalent to the probability. Right? The total area is 1. But the area of this slice is going to be far less than 1. The area from this dashed line the whole way to the left, for example, this area here will be 0.5 or a half. So this is going to be way less than a half. So we're going to look up, we're going to get a z-score, we're going to get an area associated with these two scores, and then work out the area of the slice, if you like. So I'm looking at the exam paper here, and I'm going to the standard normal probabilities, and I have z-scores in front of me here now, and I can look up a z-score for 0. When z is 0, that returns an area of 0.5. 0.5. Now this indicates this area here shaded in green, right? Which we could kind of know depending on how much practice we've done at this crack, right? So that's equal to 0.5. Now we're going to look up and get a z-score for z2, if you like, there for 0.8, right? And when I look that up on the table, this is table B on the exam sheet, table B, 0.8. That returns 0.7881. Now to be careful here, because I'm going to shade this now in purple. This gives us this area here the whole way back along, right? So we're going to have to subtract the green stuff from the purple stuff, right? So I'll just scroll down a little bit more. So the area that we're looking for is going to be 0.7881, which is the purple stuff minus the green stuff, which is 0.5, and when you do that, you're going to get 0.2881, and that's equivalent to the probability. The probability of what? We've nearly forgotten already. That you're going to land with a sample size between 266 and 268, right? So what's the question again? Find the probability that they have that the sample of 100 has a mean pregnancy between 266 and 268 days. Well, the answer, the probability, equals 0.2881. And if you wanted that in percentage, you'd multiply by 100, bang, bang, you'd hop the decimal point, and you get 28.81%. So that's your answer there.